So, good morning everybody, and I heard the cricket went very well, so congratulations. So it's always a pleasure to be here. I have now 20 years visiting India, and I see many faces I know, so thank you for inviting me. And a special thank you to the organizer and Dilip to give me the chance to speak here at this conference. I will talk about hybrid stabilization solutions for plastics, and here you see the content of my presentation. I want to speak a little bit about SONGWON because SONGWON will show you our commitment we do here in India, and that's why I want to elaborate a little bit about this area. And then I have a section on thick section polyethylene with a focus on rotational molding, and a second section on TPO for automotive, and then I conclude. So, SONGWON is in the area now since 50 years. They started in 1965, and it was a family-owned business, starting the business, and the headquarters of SONGWON is in South Korea, in Ulsan, which is in the southeast of South Korea. The family started the business in the PVC stabilizer business, and we still do today the PVC stabilizers, but mainly in Korea and in the adjacent countries. Today, we are the second largest producer of antioxidants worldwide, and we have a real global organization, and also the team of SONGWON is very international. We are very active in many different industries, and I would like to highlight that we are not only in the plastic industries active nowadays. We have also a new product range for coatings, for instance. We recently started a product range in the lubricant market. We are in electronic materials for TVs and so on. So SONGWON really tries hard to build new businesses next to the polymer stabilizer business, which is, of course, our core business. SONGWON is structured today into 4 business units. I represent today the polymer stabilizer business unit with the presentation, but we have recently also introduced 3 new business units: the fuel and lubes antioxidants, the tin intermediates, the PVC stabilizers, and the polymers like the TPUs. And we have also a specialty chemicals business unit. What is very important for us, what is very important for SONGWON is the innovation part, and you will also see throughout my presentation that SONGWON is focusing more on innovation, and a very important element for innovation are the people. We have this year opened a new building for R&D. The building is in Korea, where we have now all the R&D people doing synthesis work in one building, and I have also my team, the global application community in the building with all the extruders, injection molding machines, where we can do trials in terms of application development work. So this was for us a very important step to have both groups, the research group and also my team, the application development team, in one building, and we are very happy that we could open this this year. The other important step, and this is what I said already earlier, SONGWON is very committed to India. We have the Panoli site where we produce the famous Songnox PQ, as you know, which is a very important antioxidant for the Indian market. But we recently opened also a pilot plant, and this is a very important step for us. You know, India has very skilled people in R&D. We can do development work now also in India, and with this building here we can introduce new products. And this is a very important element. To be successful in the market, you need the research people, as I said, in Korea, who can start work in the lab, but then you need also the means and the capabilities to introduce the products into the market. And here this pilot plant will help us to scale up products, and you will see that we are introducing more products which will be now produced in India for the global market. So we are in a old industry. You know, the plastics, the LDPE started 1930. The high density came in the 50s. The LLDPE came in the 70s. We have the metallocene resins beginning of the 90s. So we are already quite a while in this industry, and also the additives are quite old. The major antioxidants have been invented in the 60s, were launched in the 70s, so we have quite some time already in this industry. Also, when we talk about the light stabilizers, most of the light stabilizers which still are used today are coming out of the 70s. But there is still room to specialize products for certain niche applications, and that's basically the idea of my presentation today, to demonstrate that there's still room for development and still room to make you as a customers more successful with products from SONGWON or others. So I want to focus on thick section polyethylene, also on durable applications. You see here UV8, UV16, a typical term for rotational molding. And I want to focus on automotive applications. Automotive applications in terms of interior applications, and especially there the secondary effects are changing, and I want to address these secondary effects. We do this with our partner, all this development in the light stabilizer area we do with SABO. SABO is today the second biggest house producer worldwide. They have 3 production sites, 2 in Italy and 1 in Mexico, and they are backward integrated into the intermediates of house, so they are a very strong player. And that's why this partnership with SABO is for us very important. We are the exclusive distributor outside of Europe and distribute the SABO products outside of Europe exclusively. What we also do with SABO is joint development, and the examples I'm showing today are basically an outcome of this joint development. And this shows you and demonstrates you that this cooperation is a real one, a strong one. So the example I want to touch today is rotation molding, but this also applies for any other thick section polyethylene application. And when you look at the market, here I have an example of the biggest market worldwide. It's the American market. You see that the market can be segmented in different portions, and you see basically the most attractive portion is the tanks market, which you see here in blue, followed by containers and industrial, and then there is a big toys segment. So the market can be nicely segmented, and also when you look at the polymers which are used, you see LLDPE, the dominating polymer used in rotational molding, followed by other polymers. So tanks and containers are the key focus for light stabilizers. And when you go back to the history, you see in the year 2004, a first tank grade has been offered with the UV20 ranking. UV20 means 20,000 hours in artificial weathering, and this can then be translated into an outdoor performance. Then you saw in the year 2008 already a UV24 grade on the market, and in the year 2011, 2 key American resin producers changed their major product grade from UV8 to UV16. So what does this tell you? There is a clear trend to give performance, to provide extra performance in terms of durability in the market, and it's even possible to make UV36 if the polymer is pigmented. So you have now these key segments: unstabilized, natural, UV0, UV8, a long-term protection, or going up to UV24, where we say it's exceptional. And how do now the different applications fit in? So you see basically on the bottom the indoor consumer articles, a lot of toys. We call we place them in the UV4 section. Then you have the bulk containers in the UV8 section, and the tanks for water, which are used a lot outdoor, or also chemical tanks in the UV8 to UV24 section. So now let's go to the introduction of our new development. You see here the EXP UV0217. It's still an experimental product, and you will learn later why it's still experimental. The product is suitable for UV12. So what do you see now on this graph? You see on the graph, on the x-axis, you see hours. It's the tensile strength retained at 50%. And you see three different concepts: unstabilized, then a reference at 3,000 ppm. The reference is a high molecular weight house, and then our new development, the EXP UV0217. So the experiment is done in a natural grade. The resin is, this is important, it's a linear low density, a unipole resin. It's a special rotation molding grade with the right MFI and density. So that was important for us in the experiment, to be on a very realistic side. What you nicely see is that the classical hulls contribute to the light stability. You get into the range of UV6, but the new development which we are proposing, the EXP UV0217, outperforms the reference at similar loading, which makes the offer very cost efficient. We see a similar effect also in pigments, and as you know, most of the rotational products are pigmented here, a green inorganic pigment. So you see a similar trend. The high molecular weight hulls a little bit better performing, and a slight reduction on the EXP. That's the effect of the pigment. And we have done the same experiment also with the black, with carbon black. Here the high molecular weight hulls at 3,000 ppm perform similar to the EXP UV0217, and we will introduce maybe at the next conference a new concept which is specially designed also for black applications with the special UV package. So what you see, this if we summarize this section here, you see that the EXP UV0217 is very suitable for grades up to UV12 in the rotation molding area, but they are as well very suitable for any other thick section polyethylene application, injection molding pipes, for example. And you see especially the very good contribution if you have an unpigmented resin. And we believe if you use an organic pigment, the performance will be very similar, because there you have typically also very often a translucent system. So the second system we want to introduce is the EXP 0117, and this grade is suitable for the second important class of the rotation molding requirements. It's the UV16 area. So again, a similar setup. We use the same resin, the same rotational molding resin, a unipole linear low density resin with the appropriate MFI and density. And you see again the comparison of unstabilized, the high molecular weight hulls, and then the new development of SONGWON. Again, on the bottom, the retained tensile strength, an important requirement of the rotation molding industry. Here again, you see that this EXP UV117 outperforms the classical hulls, and we reach the required UV16 range at a loading level of 0.3% or 3,000 ppm. We have an almost similar trend if we use a green pigment. You see again the green pigment with this system slightly reduces the light stability, so there's a slight antagonistic effect, but this is very typical, and that's why it is important to understand the pigment dimension when you bring a product onto the market. And in the black, we see a very good contribution of the EXP UV117 in the black area. And you see also that the high molecular weight hulls gets a boost when you combine the high molecular weight hulls with the black, carbon black pigment. So, to conclude, we have now this second grade, the EXP UV117 for the UV16 range, and depending on the loading level, we can go also above the UV16 range, and we think that this system is very cost efficient. So how do we now position the different product ranges and that you have a good selection? You see here basically for the base, the UV4 grade, the toys, the Sabostab UV62, a very cost-efficient, high molecular weight hulls will do the job and is very suitable also in terms of color development. You have for the bulk containers the EXP UV0217, and then for the high end, the tank grades, the EXP UV117. So the SONGWON offering, to tell you more about these experimental products, they are containing a hulls and a UV absorber. We intend to commercialize the grades next year, and they have a very good food conduct approval range. I think this is very important, so you can use the products in water tank application, for instance. You have seen that they are excellent in terms of unpigmented LLDPE, and they have a low color effect, which is important. They are extraction resistant, and you all know that if you use a hulls, you have also very good contribution to the long-term thermal stability. And with these two grades, we can cover a broad range of the required UV in rotational molding applications. We can give you choices, so you have another player in this market where you can choose your supplier, which gives you security of supply. We have a global setup, which is very important, and SONGWON can guarantee you the consistency and the quality required. Of course, also this product can be combined in an OPS, because you may want to add next to the light stabilizers also the antioxidants. So in conclusion, we have a very good system for polyethylene 6-section. This was a very intensive study which we have done to understand the requirements of the light stability of polyethylene, and with these two grades, we can cover a wide range of requirements, and the products will be commercial next year. So now the second part of my presentation. In the second part of my presentation, I want to cover the automotive section and especially the TPO, and I want to give you an interesting example of what can happen And I think this is an interesting story. So, we were using in this experiment a commercial TPO grade, which is used in the industry. The commercial TPO contains talc, it contains nucleating agents, and it contains also the appropriate TPO portion. And the interesting thing in this experiment is the following. So you see here now on the x-axis the concentration of the light stabilizer, and on the y-axis you see the onset of crazing. Onset of crazing gives you a first indication on is the material deteriorating, or do you see the first sign of degradation due to the impact of light. The interesting thing you see here is, and this is basically the blue curve here, that the classical system, a low and high molecular weight hulls, which is used very commonly, is not performing in this system. So even if you increase the concentration of the light stabilizer, we don't see an effect that the onset of crazing is retarded. So there is something happening, and this is strange, and that's why I wanted to bring this example, because you need to understand what you do, and sometimes the classical systems are not doing the job. And you see with the orange curve, where we have introduced two systems, the Sabus WV228 and the Sabus WV229, that they perform very well. So if you increase the concentration of the light stabilizer, you see that the onset of crazing is retarded. So why is this? It was really a surprise, because we all know the classical low and high molecular weight hulls combination works very well in polypropylene. So what we think, and in this special system, is that you need to understand also the secondary effects. You know, it's not only the light stabilizer performance, it's also the secondary effect, which is very important. And the challenge we have is we need a portion of the light stabilizer which is migrating, and we need another portion of the light stabilizer which is protecting the bulk. We don't want that the light stabilizer is too volatile, because it will affect VOC, the volatile organic content. And the challenge is, do you have a good system, and do you have the right system? So I'm running out of battery, I'm sorry. There is no power supply. Okay. But I'm almost at the end of my presentation. So what do you see here? Here you see basically the solubility of the additive. And what is the story here on the solubility of the additive? So if you go to the top line, the low molecular weight hulls is not very soluble in here in N-hexane, where we also can conclude it's not very soluble in the polymer, so it may tend to bloom. We have other UV absorbers, for instance, which, for instance, the SONGWON 3280 is very soluble, but it has other concerns today. It may go onto the super very high concern list, and we may not be able anymore to sell it. And we have the SONGWON 8100, a very soluble UV absorber, but the performance is not the best. And you see here the hulls which you saw, the Sabus WV229 or the Sabus WV228. They are a combination of the Sabus 91. The 91 is slightly more soluble, so the compatibility in the polymer matrix is better. And we have a second additive, the benzoate, the aliphatic benzoate, the SONGWON 2908 in the system, which gives you a very good surface protection. So in conclusion, it's very important to understand the polymer matrix, and surprisingly, sometimes the very well-known classical system don't work, and you need to go to a different system, to a very robust system. And our Savostab UV228 or the Savostab UV229 are a very good system, very robust system for TPOs and give you the required performance. And they also don't contribute to VOC because the balance between the molecular weight and the diffusion speed is very well optimized to have here almost no effect. So to conclude the overall presentation, I wanted to show you that SONGWON is committed to India, that we further invest here. We have invested in a pilot plant, and we are proud to be here in India. I have introduced a section on rotational molding or thick section polyethylene, where we introduced 2 new products. And I gave you an interesting example about TPO. So if you don't know your system, things can go wrong, but there are always alternatives around to fix the problem. So here a slide on the core values of SONGWON. We are customer-focused, passionate, committed, and I hope I could demonstrate with my presentation a little bit the culture of SONGWON, and close with a big thank you, and I'm happy to answer any questions. Thank you.
Do we have any questions for Thomas Schmutz? So the request is, while you're asking a question, please do identify yourself.
Hello, this is Francis from Plastic Plains, India. The question is, you presented some slides on unpigmented stabilization versus black. Now, black being a very good stabilizer, absorber, one would have expected an enhanced effect, but you are still at 36 UV. Why is that so?
So as you rightly said, the carbon black is a very good UV absorber, so it helps. You see it also when you don't use any light stabilizer, you will see already a positive effect. The surprising thing was with this particular combination, the experimental product which we have is a combination of a high molecular weight hulls with a UV absorber. The addition of the UV absorber did not contribute in the carbon black because the carbon black is doing the UV absorber job, but we have another system in the pipeline which we want to launch, which will have even a positive effect on the carbon black system. But rightly, as you said, the carbon black does an excellent job here, and then you don't need the additional UV absorber. And then normal hulls, or we have another idea what can be done, would give you the performance.
Is it possible that there's some antagonistic effects in play here between the stabilizing system and the UVs, carbon?
Yeah, we are always concerned about absorption of the additives on very active systems like the carbon black, so this could be maybe one effect that one of the additives absorbed on the surface of the carbon black and is not contributing. Yes, thank you.
I am Ajit Deshpande from Lifelab Technologies, Thane. We are regularly manufacturing combo batches, means the pigment plus UV. And while making the master batches, we observed that the UV is migrating on the surface of the master batch. My question is whether it is reducing the concentration of UV when the customer is actually using, and how we can avoid to migrate UV on the surface.
So thank you very much for the question, and especially one of the systems we were showing here gives you higher performance. So the experimental grades I introduced, so the consequence is then if you make your combi master batch, you will need less of the UV portion, and the chance that you have less migration is high. So it's a very smart strategy to use light stabilizers which are more efficient so that you can reduce the overall concentration. This has an effect in the master batch, but also in the end article. I agree, yes.
Okay, thank you.
Thank you very much, thank you.